Hello students. So now we are going to solve another numerical on convolution theorem where we'll be dealing with the error function. So let's see how do we get error function by using convolution theorem. So here we have to find out the inverse Laplace transform of 1 upon s into square root of s plus 4. So guys, here since we have to use the convolution theorem, here we'll be following certain steps to get the answer. So here on the screen you can see the convolution theorem which says L inverse of phi 1 of s into phi 2 of s is equal to this. It means the function which is given to find out inverse Laplace transform is a combination of two functions phi 1 and phi 2. So therefore the step number 1 is consider the given functions as phi 1 of s and phi 2 of s. Now guys, here I have two functions, that is 1 upon s and 1 upon root of s plus 4. So I can consider any one of them as phi 1 of s and any one of them as phi 2 of s. So here I'll say let So here I have considered two functions. Now guys, make sure that the multiplication of these two functions must be your question. Now let's follow the step number 2, which says we have to find out the inverse Laplace transform of phi 1 of s and call it as f1 of t, and then find out inverse Laplace transform of phi 2 of s and call it as f2 of t. So here I'll find out that. So here I'll say now guys, here to find out the inverse Laplace transform of this function, it is matching with one of the property which is called a shifting theorem. So by shifting theorem, I can say that this is nothing but e to the power minus 4t into inverse Laplace transform of 1 upon square root of s, and square root of s is s to the power half. Now guys, it means I have to find out the inverse Laplace transform 1 upon s raised to half. And guys, here I have applied the shifting theorem. So if you are not very well with the shifting theorem, you have to go back to my videos of shifting theorem and make sure that you are very well with the shifting theorem, and then only you will be able to get these answers in the similar manner as I am getting. So here this e to the power minus 40 as it is. Now we have to find out the inverse Laplace transform of 1 upon s raised to half. Now guys, that half is the power and that is in the fraction. So whenever it comes in the fraction, we always use the gamma function. So by the formula of inverse Laplace transform, it is nothing but t to the power negative half upon gamma half. Now guys, the value of gamma half is root pi, we all know, and let's call this as f1 of t because it's the inverse Laplace transform of first function. Similarly, I'll find out inverse Laplace transform of second function, that is now guys, inverse Laplace transform of 1 upon s is 1, and that is my f2 of t. So here I'm done with step number 2. Now let's start with the step number 3, which says find f1 of u from f1 of t by replacing this t with u. And step number 4 says find f2 of t minus u from f2 of t by replacing this t with t minus u. So I'm gonna do that. So here value of f1 of t is this. I'm gonna replace that t with u so that I'll get f1 of u. So here I'll say therefore f1 of u is equal to e to the power minus 4u into u to the power negative half upon root pi, because the value of gamma half is root pi. Next, let's find out f2 of t minus u, but guys, here in this function there is no t, so its answer is gonna be 1 only. So therefore f2 of t minus u is equal to 1. So I got both the values. So now we are going to apply the last step, that is apply the convolution theorem, put these two values here, multiply it, integrate over 0 to t and get the answer. So here I'll say therefore So guys, here I have substituted the value of f1 of u and f2 of t minus u. Now let's find out the integration of this function. So here I can take 1 upon root pi outside since it is a constant. But guys, if I want to find out the integration of these two functions, and if you are thinking that we have to apply the u into v rule or Eilert rule, then you are making a mistake, because here if we use that Eilert rule, then this is an algebraic function and its power is negative. It means if I find out derivative of it continuously, then it is not gonna become 0. So getting the integration of this term is quite difficult. So how to get answer of this integration? So guys, here I'm gonna use the integration by substitution method. So what I'll do here is I'll substitute this 4u as x square. So here I'll say put 4u as x square. Now by doing that, we will get the limits for x. So for u, limit is from 0 to t. Now to get the limits for x, let's put u equal to 0 here. So we'll get x square as 0, therefore x is 0. And if I put u as t here, I'll get 4t. So x square equal to 4t, and the value of x is 2 into square root of t. Now this is the value of x. Now what we'll do is we'll also find out the value of du. So I'll differentiate this. Here I'll get 4 into du equal to 2x dx. So value of du is 2x upon 4, that is x by 2 into dx. So let's put this value in the integration. So the integration will become integration 0 to 2 root t. Here we will get e to the power negative x square. Then u raised to minus half. So value of u is x square upon 4. So guys, let me tell you the value of root u over here. So since u is x square upon 4, if I find out the value of root u, it is x by 2. Now this u to the power minus half is nothing but 1 upon u to the power half. That is 1 upon root u. So it means guys, the value of root u is x by 2. I'm going to put this value in the denominator. So here root pi as it is into 1 upon u raised to half, and value of u raised to half is x upon 2. Next we have du. So value of du is x by 2 dx. So here I'll write down x upon 2 dx. Now guys, we can cancel here this x with x and 2 with 2. Root pi will come outside, so this will become 1 upon square root of pi, and we'll get integration over 0 to 2 root t e to the power minus x square dx. So guys, what is the value of this integration? So let me tell you that there is a definition of error function, and this matches with the definition of error function that says that error function of root t is nothing but 2 upon root pi into integration over 0 to root t e to the power minus x square dx. Now guys, if you see here, then if I multiply this function by 2 and divide by 2, then we'll get 1 upon 2 into 2 by root pi into integration from 0 to 2 root t e to the power minus x square dx. And if you'll see, then it is exactly matching with the definition of error function. So this is the definition of error function of root t, since the limit is from 0 to root t. Now here our limit is from 0 to 2 root t, and therefore I'll say this is nothing but error function of 2 root t. So guys, here the answer is half into error function of 2 root t. So here we got the inverse Laplace transform of given function, and I'm sure that you understood the video. So don't forget to share it with your friends so that they can also get benefited through these videos. So guys, keep watching the videos, and thank you very much for listening me.